Hello, everyone, and those of you at the back who are still having a chat. My name is Emil Velikov, and today I'm going to talk about robust GPU device selection in GL. Some of you may know me. I'm a software engineer and collaborator. I've been working on Mesa more or less since 2011. Personally, I'm involved in pretty much anywhere in the graphics stack, from the kernel to Mesa. I've been through the X server, occasionally through Wayland. I'm not a person who will work on the fashionable parts of the stack, so perhaps my name is not going to be that much familiar to you. So here's a bit of an outline of this talk. I'm going to give you a very quick intro of OpenCL EGL in the context that we're interested in. I will talk about why we're so interested in device selection, the current solution that we have in place, the actual evolution of EGL GLX, and the status of those. First thing, OpenCL, EGL, and GLX. As you know, the OpenCL originates in the 90s, which makes it a fairly ancient API, but due to the modular infrastructure, this allows us to extend it via extensions. Additionally, it is a rendering API, so it doesn't really matter in our context all that much, unlike the Windows system binding APIs like GLX, EGL, and others, which we're not interested in here. It comes perhaps the most important part. Why do we need that? There are multiple concerns for multiple parties. My personal interest is mostly in terms of testing. There are two main concerns. The first one is the actual physical presence of machines. And since you can fit multiple devices on the same physical machine, such as a couple of, depending on the machine, multiple AMD GPUs and NVIDIA GPUs, you can fit them a lot better. And additionally, we're fairly interested in the test interaction with the windowing system. Since, unfortunately, we had quite a few cases where all the CTS pass, all the tests that we have that include also CTS, Vulkan, Crucible. I believe Mark James is going to talk about it a bit more later on. Again, all the tests pass, and we had multiple cases where, well, your desktop is completely rubbish. From a developer point of view, obviously you would like to know what kind of GPUs you have. So if your application does require a specific context or a specific memory requirements, or it can work on very low power GPU, obviously you can select that one or provide that choice to your user. Additionally, you can use all this for separation to prioritize. Let's say one of my GPUs will be running a, let's say, high performance or timing critical job, whereas another one will be, let's say, doing my desktop compositing. The current solution that we have in Mesa is fun. It's called DRI prime. It's an environment variable, and as I said, it's Mesa DRI specific. It more or less asks the server, can you give me the name of the other GPU? And if you have more than 2 GPUs, it will give you something. Additionally, it has another interesting drawback, that by giving you the other GPU, you do not know if that GPU has changed across reboots. As I mentioned as well, it talks to the X servers, so if you're running anything Wayland, well, and as I said previously, there's no selection. Games do not know about it. I believe some developers might even set that variable themselves before running their game. As I mentioned, originally DRI prime selects the other GPU. Shortly afterwards, the path ID tag was introduced. As some of you know, the path ID tag is a property that you can query quite easily with UDEV. But as you can see in the example in there, it actually describes the bus, not the device. So what would happen if your old device burns out or you'd like to update your GPU? Well, it will give you something, but probably not the one you want. Additionally, we have another interesting solution, right? It is libgeo or software. It's yet another environment variable. Again, software, not software, but Mesa specific, which effectively gives you the software driver, which quite often is good, quite often is what you want. But that shouldn't be the way to select that. And additionally, we have a very interesting heuristics, which effectively falls back to the software device if how the driver initialization fails. So for those of you who actually want performance and fall back to SWRest, I'm sorry. The next part will be the evolution. So EGLDevice is a set of extensions originally designed by NVIDIA, I believe. The top one, the EGLDevice base, provides a couple of things. First and foremost, it defines the concept of device and device extensions. Secondly, it provides the means to query and enumerate those devices. At this time, there is no specific means to provide additional information from the device themselves beyond that, hey, I'm a DRM device or I'm a software device. As you can see in there, the software device is an extension proposed by Adam Jackson. It was on the Mesa mailing list. And although I have implemented it, I'm yet to double check with Kronos and make it part of the official EGL registry. Another extension at the bottom is a copy from the GLX Mesa query render extension, which I have locally, which provides, I would say, fairly basic, but at the first step, very useful information for developers and other people who would like to know the device specifics, such as is this a PCI device? Is it like NVIDIA device? What's the actual PCI ID? The size of the memory RAM? What kind of context it supports, what kind of version for the different contexts it supports. So would that be core, compatibility, GLES? Additionally, we have a couple more extensions. Some of you may know there is this concept of native platform. EGLDevice starts with creating a EGL display based on the native platform. So the first extension, which is an official extension, considers the EGLDevice as a base platform. Hence, you will be able to do rendering without actually needing a windowing system. If you have one, the driver should be able to work perfectly fine behind the scenes, which is good, but it doesn't help us with one of our use cases, which was to see how a specific device works with the windowing system. So there is this second extension, explicit device, which was proposed again by Adam Jackson. There has been a bit of discussion on that, but I'm yet to quickly go and double check all the details. It allows you to combine a specific device with the platform you're interested. So for example, if you have multiple Wayland servers and you want to connect individual EGL devices to individual ones, you can actually do that and obviously test it. As a brief outline at the bottom, I have some information of how the pipeline works. So you have your list of devices, you enumerate, you select the one you want, you create the display, config, and context. I'm giving you that as an example since we'll have a not so obvious flow with GLX in a moment. So the next thing is GLXDevice. Unfortunately, there are no such extensions, partially because GLX has been partially because GLX hasn't seen any action in quite a few years, and partially because working with GLX is a little bit hard at times. We have the extension GLX Mesa Query and Renderer, which I believe Ian Romanik wrote a good 5-10 years ago, which, as mentioned, provides basic information such as vendor ID, VRAM, etc., etc. But it also provides the dimension or the notion of a renderer. Sadly, it does not define anything in there, just refers to another potential extension. So this is one good starting point that we might want to explore. As mentioned, the flow between EGL and GLX varies a slight bit. There is no notion of GLX display. So your usual application will open the actual X display, will get the config, and then the context. Obviously, you can use XCB in the case, which is going to be XCB Connect Display, I believe, and so on and so forth. And my current idea is to place the device just after the connection has been established. That is because, unlike EGL, GLX has server-side implementation, which you need to check before pretty much doing anything. Not to mention the GLVND project, which was started from NVIDIA, which aims to allow multiple vendor libraries to coexist at the same time. Excuse me. Obviously, there's a workshop session a little bit later with Kyle, which we'll discuss and see how things are going to go. But fingers crossed, everything's going to be working fine. And more or less, the final stages, the implementation status. So we have the list of extensions, what's merged, what isn't merged. I noticed the comments on the last iteration of EGL extensions. I'm planning to sort this out maybe today, maybe tomorrow, depending on how much time I find, and ideally we'll get them merged. Obviously, there is the explicit device and the query render that will need to be iterated at least once or twice, and ideally we'll have those merged at some point. Pretty sure I went really quickly. Yes, I did, extremely quickly. So, thank you. Questions?
Any question?
So you talked about interfaces for the application to choose a device, but DRI prime, the environment variable, could be set by, for instance, a compositor, like I think GNOME Shell does it, to let the user select launch an application and the discrete GPU or on the integrated GPU. So do you have plans to do something like this but better to let application launchers or the user just use a generic way to make Mesa use a specific device or something like this?
Can you just repeat plans to more or less address that in the launcher, or address that in GNOME?
For instance, I'm a user and I want to play a game and I want the game to use a specific device. And I don't want to, if the game doesn't use these extensions, is there a way to use an environment variable to select a specific device? In the case of 3 GPUs, for instance?
Okay. So your question is something I just discussed with Mario a second ago. What would happen for games or applications in general which do not use the API? In theory, you can write a very, very trivial and easy ellipEGL, which will look for specific mappings that you can expose either via variables or via configuration file. My personal preference is always configuration file. But ideally, you will have the game updated, considering the changes required are in the order of 50 lines to 100 lines of code. Personally, I do not have yet intent to update launchers or provide, let's say, a shim like that. I might have a chat with Kyle if we can have such feature in, let's say, in GOVND. Personally, I see it as a worthy addition. I'm not sure how the discussions are going to go, since obviously it's not just my opinion that matters. It is other vendors, it is community as well. So.
So this isn't a question so much as a comment, but the device selection stuff is something that we've been running into in the Vulkan world as well. And it's
Can you speak a little bit louder, please?
Sorry. The device selection stuff is something that we've been running into in the Vulkan world as well, and it's kind of awkward there because we do effectively have the explicit device API, but applications don't know which one the user actually wants them to use.
Yep.
And so they have all these heuristics like first check for NVIDIA, then check for AMD, then check for Intel, or some guess as to how powerful the card is. And so like I would personally be very supportive of some sort of, I don't know if it's going to be a layer, a shim, or what, but some way of providing the application, the user a way to configure policy around I want to run games on my NVIDIA card, and I want to run everything else in the Intel card, things like that. So I know you just said you don't have any plans, but if you decided to have plans, I would be very supportive of those plans.
Oh, thank you.
More questions?
Well,
Okay. Remember that we have a workshop about this later in the afternoon. Please don't forget it.
yes, the workshop is at 3:45, I believe, later on this afternoon. So anyone interested, feel free to join us. Thank you.